Hello, everyone! In the following video, we will show you how to issue new shares to external investors in the ComBoox system. Step 1. Retrieve the target company from the ComBoox system. Look at the target company's homepage. We can see that the target company has 5 shareholders with the following user IDs. For convenience, we will refer to them by their share numbers: shareholders number 1, number 2, number 3, number 4, and number 12. When issuing new shares, this is usually done by the company's de facto controller or controlling shareholder. The first thing to do is to create an investment agreement. Please go to the Register of Agreements section. This section records all versions of investment agreements in the company's history, including external share transfers, internal share transfers between shareholders, and the capital increase agreement we are about to create. Click the Create IA button. The system will create a clone contract based on the already deployed template contract, generating a new smart contract object. You will see that this new contract appears in the investment agreement list, the newly added row. The current status is created. Click the link in the first column, and the system will take you to the investment agreement user interface. This interface consists of 5 main sections. Currently, the body terms section is displayed. To edit or draft this investment agreement, we first need to appoint an external lawyer to operate. Of course, if the shareholder has the necessary business and legal knowledge, they can also appoint themselves as the lawyer for the smart contract. Now, suppose we introduce an external lawyer, account number 2, as the drafting lawyer for the smart contract. Copy the address of account number 2, paste it into the corresponding field. Shareholder number 1, the creator of the draft investment agreement, authorizes account number 2 as the administrator of the lawyer role group for this smart contract to draft the clauses. Now we switch to the identity of account number 2, log into the system, and let this user set the specific clauses. As you can see, the operation panel is similar to that for share transfers. The upper part is the Create Deal section, which contains attributes that the drafting lawyer needs to fill in. After setting them, click Add Deal. The system will write the target transaction into the smart contract and display it in the deals list below. Because we are issuing new shares externally, please select the first option, Capital Increase. At this point, the system will automatically pop up an input box for voting weight, that is, the voting weight of the newly issued shares. By default, the system assigns a new share class to the newly issued shares. So, what should the voting weight of this new share class be? Generally speaking, apart from the founder shareholders, the voting weight of other shareholders is set to 100%. Next, we fill in the class number of the newly created shares. We have set a counter in the system backend that increments sequentially. Please note, if you enter a number larger than all existing numbers, the system will automatically reduce it to a smaller valid number. We just need to fill in the class number directly. Next, fill in the price information. 2 fields, the par value price and the paid-in capital price. Usually, we set the paid-in capital equal to the subscribed capital. In that case, the par value price has no substantive meaning. The system will calculate the total amount of the capital increase transaction based on the paid-in capital amount. If the subscribed capital is greater than the paid-in capital, the difference will apply the subscribed capital price. We designed this price system to meet the arrangement needs of specific companies. For example, some companies only issue shares but keep them unpaid, operate business at the subsidiary level, and transfer the value of the equity holding platform at a symbolic price. It may not be appropriate to set both the subscribed and paid-in capital to 0 consideration, and that would also fail to meet corresponding business needs. Therefore, under normal circumstances, we set the subscribed capital price and the paid-in capital price equal, for example, both set to $2. For the transaction deadline or closing deadline, we usually set it to 30 days. The current on-chain time is July 13th, 2026, so we set the deadline to August 13th. For the buyer field, assume the potential buyer is account 5 here. Let's call him user number 5. We treat him as an independent entity with no other related parties joining the company as new shareholders or acting in concert. So in the group of buyer field, we directly fill in this account's user ID. Next, the par field. Fill in the subscribed capital amount. Simply assume we issue 1,000 shares. The paid-in capital amount is also 1,000. That is, we will issue new shares to user number 5 with share class number 3 and both subscribed and paid in capital of 1,000 United States dollars. Now, click Add Deal to confirm. A new row will be added to the transaction list below, recording the transaction conditions we just entered. Similarly, in the signature page, we set that the parties must sign within a specified period, for example, 90 days. If the closing has not occurred after 90 days, the seller can terminate the contract. The system will automatically release the locked target shares back into the system. For a share transfer, the seller's clean paid would be adjusted to equal the paid-in capital. For a capital increase, this capital increase arrangement would be canceled. Next, we fill in the buyer's user ID. Then we fill in the seller's user ID for the transaction. For a capital increase, we usually set the seller as the de facto controller. This will cause the de facto controller to lose the chance to vote. The system will not treat him as an eligible voter. However, according to the voting rules, the system may either count shareholder number 1's voting weight as a yes vote or completely exclude him, i.e., recusal of related parties. In some cases, for example in a share transfer scenario, we might set the voting rule to treat an abstention as consent. This is the default statutory rule under the Chinese company law, unless we actively exclude it when editing the shareholder agreement. That is, directly modify this rule in rule number 2, the voting rule for external share transfers. Now we have filled in the 2 user IDs on the signature page, meaning that in the future only these 2 users can sign this smart contract. After setting the body clauses and the signature page, we jump to the life cycle section. The creator of the agreement, shareholder number 1, does the final review, confirming that the clauses meet the commercial arrangements. If everything is fine, click the Finalize IA button. The system will set the smart contract creator address and all lawyer role group addresses to the 0 address. This means that no external Ethereum account can modify the contract clauses any further. If there are tag-along or drag-along arrangements, the smart contract will take over. Subsequent modifications are to be made without human intervention. Then, we refresh the screen. As you can see, because it has been finalized, the access control section is no longer displayed. In the second step, the circulation process, the contract creator can set a hash pointer, pointing the on-chain smart contract to a specific storage location where the natural language electronic document is drafted. For example, upload the smart contract to the IPFS system. Take the content addressed hash value assigned by IPFS and fill it into the upper field. Alternatively, store the electronic document on a company's server, compute the hash of the server IP address or domain address, and fill that in. This allows reverse verification of the specific location of the natural language contract document bound to the smart contract. The lower field is used to set a content pointer. The electronic document can be hashed using a specific hash algorithm to produce a hash value, locking the specific natural language electronic document and making it tamper-proof. This establishes a one-to-one mapping between the on-chain smart contract and the off-chain natural language electronic document. Of course, this is a one-way, reverse verifiable relationship. If you use IPFS content addressing, the upper pointer can directly link to the electronic document. If you only fill in the file hash, you lock the file content but cannot directly find where the file is stored through the hash function. This has pros and cons. The advantage is confidentiality. External on-chain investors cannot see the details of the natural language contract, such as closing conditions or post-closing obligations. Even third parties searching the on-chain corporate governance file archives cannot obtain these details. If the company deems it necessary, it can also encrypt the natural language and electronic document. For example, the document uploaded to IPFS could already be ciphertext, and the decryption key is shared among shareholders, so the public can only see the encrypted document. Specific encryption schemes, symmetric encryption, asymmetric encryption, or PGP encryption, we will not elaborate here. For this demonstration, we use a simple method. Input a sentence. Let an online hash calculator using keycock 256, the same hash function as the Ethereum blockchain, compute a hash value, and then fill it into the document content hash field as the hash pointer of the natural language electronic document. For example, we write, "This is a capital increase agreement drafted by shareholder number 1. The online calculator automatically computes the hash value. You copy and paste it into the corresponding field in the ComBoox system, locking the file content. If any punctuation in the original file changes, the hash value will change dramatically. Click Confirm. The file status becomes sent to relevant and interested parties for circulation." Let's go back to the investment agreement register and take a look. The status of this draft has become circulated. Next, we ask the relevant parties to sign the document. For signing, you can also take a handwritten or sealed document, scan it, compute the hash of the PDF file, and fill it in to lock the integrity of the document data. Here, for simplicity, we fill in the number 1 to represent the hash of shareholder number 1's signature. Then click the Sign button. The prompt box will show that 2 parties need to sign and 1/2 has been completed. We then switch to user number 5, ask him to sign this agreement. We simply change the hash value to 5, then click the Confirm button, the Sign Agreement button. The system will then move to the next step. This means that the contract has been circulated for signatures. The next step is to submit the draft agreement to the company's shareholder meeting for review and voting. Only when the transaction receives the necessary voting power required by the shareholder agreement can it proceed. As you know, the shareholder agreement may include certain special shareholder rights, such as preemptive rights. Now we submit this investment agreement to the company's shareholder meeting. When submitting, there is a text box to fill in the executor of the document. We usually fill in the relevant shareholder. In the investment agreement context, the executor has no substantive rights. In the shareholder agreement context, the executor can activate a new version of the shareholder agreement, and the binding effect of the old version will be automatically revoked. Now we switch to shareholder number 1 as the de facto controller of the target company. He submits the signed version of the agreement to the shareholder meeting. At this point, the system prompts that we are still within the drag-along and tag-along exercise period and cannot submit for voting. This is actually an interceptor mechanism set in the smart contract to ensure that holders of special shareholder rights have enough time to consider whether to exercise them. For example, preemptive rights, tag-along rights, drag-along rights, etc. So we now need to advance the test blockchain time forward by a certain period to satisfy the system's requirements for special shareholder rights. Let's look at the timeline of this investment agreement. There is a signing period, a preemptive rights exercise period, and a tag-along, drag-along exercise period. Only after all these periods have passed can the signed agreement be submitted to the shareholder meeting as a special motion for review and voting. Therefore, we now need to advance the on-chain time forward to after July 16th. Let's check. The current on-chain time is July 13th, meaning we need to advance by 3 days. Now we go back to the ComBoox system. Shareholder number 1 submits a special motion to the shareholder meeting. That is, he submits this investment agreement to the shareholders for review. At this point, the other shareholders should have already reviewed it, and the relevant rights holders have had enough time to consider whether to exercise their rights. Now we can see that the status of this investment agreement has become proposed. This means that the agreement has been submitted to the shareholder meeting for the shareholders to vote. We switch to the general meeting minutes interface. You will see a new motion added to the motion list, the one we just submitted. Click into it to see the motion details. The motion submitter and creator are both shareholder number 1. The creation time is July 16th. This is the on-chain time after advancing. The proposed date is the same as the creation time. Note: motion creation and smart contract creation are two different actions. A motion is an independent data object, while a smart contract is a clone contract. The voting weight is determined at the specific time of the record date for shareholding. Only users who hold shares in the company at that specific time have the right to participate in the voting during the voting period. For example, if shares are transferred out between December 30th and January 1st of the following year, the transferee has no right to vote. The transfer has the voting right. This time difference can theoretically be locked. We can also arrange a specific period to allow shareholders to exit their investments. This is flexible and adjustable. We see that the current motion status is proposed. The executor is the de facto controller, shareholder number 1. In the investment agreement context, the executor has no substantive authority. Only in the shareholder agreement context does the executor have the authority to activate a specific version of the shareholder agreement. The voting rule applicable to this investment agreement is rule number 1, the voting rule for issuing new shares or increasing company equity. We have introduced this rule before, so we will not repeat it here. The button at the back is a hyperlink button pointing to the target document for review. In the lower section, choose Cast a Vote to vote. The options are support, oppose, or abstain. When voting, we can also create a hash pointer, or hash value, to lock the content of the specific document containing our signed vote. Now we switch to shareholder number 2 and see if this user can vote. We modify the hash pointer of the vote, continue to choose support, and then vote. The system prompts an error because the voting time has not yet arrived. Voting is not allowed. We need to advance the on-chain time to within the voting period. Only during that period can voting occur. Let's check. The voting start time is July 17th. The current on-chain time is July 16th. That means we need to advance the system time by 1 day. First, let's try using shareholder number 1 to vote. We click Vote and see if the system accepts it. The system prompts an error because shareholder number 1 is a party to this agreement. So shareholder number 1 is directly excluded from the voting process by the system recusal rule. Back to the General Meeting Minutes panel. We use the identity of shareholder number 2. Choose to vote in favor of this motion. Fill in the hash value of the voting document and click Vote. This time, the system passes the verification and records the vote in the system. We can see that the current voting status for this motion shows that one rights holder has voted, and it is a support vote. Click in to see the voting details. User number 2 holds 80,000 voting rights on his own behalf. The on-chain voting time is July 17th, recorded in block 559, and the hash value of the first signed voting document is attached, locking the content of the relevant electronic document. Next, we operate for shareholder number 3 and shareholder number 4. Suppose shareholder number 3 wants to entrust shareholder number 4 to vote. Using shareholder number 3's identity, we move the selection box to the right and choose to entrust another agent to vote. In the text box, we fill in the agent, shareholder number 4's user ID, 6A865F99E4. Click Entrust. The system records that shareholder number 3 has entrusted shareholder number 4 to vote on this motion. Then we switch to shareholder number 4. He votes on behalf of himself and shareholder number 3 in favor of this motion. Choose Support. Fill in the hash value representing his own signed vote and confirm. We can see that the current voting status has become 3 rights holders voting in favor. The relevant proportions are all displayed. We won't go through them one by one. We switch to shareholder number 12. In the previous video, he obtained shareholder status and voting rights through a share transfer. He chooses to abstain. Fill in the hash value. Click Confirm. The voting status of the special motion is updated. One rights holder has abstained. shareholder number 12's voting details are also listed. Let's call it up again. User number 12 has 1,000 voting rights, and his attitude is abstention. We need to check how rule number 1 treats shareholders who did not vote. Only attendance equals false. That is, not only shareholders who participate in voting are considered, those who do not participate are also counted. Party's consent equals true, meaning the attitude of a party to the agreement is directly counted as a support vote. Therefore, although shareholder number 1 is recused from voting, his attitude is default support and is included in the final result. This motion will definitely pass. We advance the on-chain time by another day. This will put us beyond the voting period. Then the relevant interested parties can calculate the final voting result of this motion. Now we operate as shareholder number 1, the de facto controller, to advance the procedure. Please note that the system allows any user to advance the procedure. This is designed to avoid giving the right only to a specific rights holder, who might then stall the entire process if unsatisfied with the result. That would violate the decentralized intent of smart contract automation. In other words, any user can trigger the on-chain instruction to count the voting result. We click the Count button. The system backend automatically calculates whether the vote is passed. As you can see, the vote is passed. The status has become passed. Let's switch back to the ROA, the Register of Agreements contract. The status of this agreement has also become approved, meaning it has been approved by the shareholder meeting. Next, we arrange the closing. We can choose to pay using fiat currency through user number 6's account to the company's manager contract, paying the corresponding currency. Therefore, the address field here needs to be filled with the on-chain address where the target company's general manager contract is deployed. The consideration in the subsequent input box is automatically calculated by the system. The user needs to first click the stamp to authorize the payment request via MetaMask. Then, the payoff button will appear, indicating that it is clickable for payment. We can also choose other methods to issue new shares. For example, switch to shareholder number 1's account, click Issue to complete the issuance. After closing, we switch back to the target company's homepage and look at the shareholder register. We will see an additional row. User number 5 has become a shareholder of the company. His subscribed capital and unencumbered paid-in capital are both 1,000 United States dollars. Click Investment History. At the very bottom, you will see a record of the paid-in capital obligation. He received the newly issued Class Number 3 shares. Let's also jump to the company's share register, the certificate of contribution for the shares held by user number 5. The last added record shows that the paid-in, subscribed, and unencumbered paid-in amounts are all 1,000 United States dollars. The voting weight is 100%, and the class number is Class Number 3. This is exactly the share class we specified in the investment agreement. Please note, the share class number specified in the investment agreement can only be less than or equal to the system backend counter value. We cannot skip Class Number 3 and directly issue Class Number 4. Alright, that's all for this video. Thank you, everyone. See you in the next video.